We have an Atwood machine, and it's our job to figure out what the acceleration of it is going to be. I've got a 6 kilogram mass on the left side, and I've got a 4 kilogram mass on the right side. Now we can't say that up is positive and down is negative, because when the 6 kilogram block goes upward, the 4 kilogram block goes downward. And when the 4 kilogram block goes upward, the 6 kilogram goes downward. So up for one is down for the other. So you have to change things a little bit, and instead take a look at when the pulley itself is going clockwise or counterclockwise. And that is our positive or negative direction. So in this problem, I said that when the pulley goes clockwise, that's a positive thing, and when the pulley would go counterclockwise, it'd be a negative thing. So any forces that would want to make the pulley go clockwise are positive forces, and if it wants to make it go counterclockwise, those are negative forces. So I've already drawn my forces on each block. I've got tension up and force of gravity down on each one. And what I do when I have more than one object is I have to make an equation for each object. So I'll start with the purple block. I'll call this block 1, hence I call it force of gravity 1 acting on it. And the positive force acting on the 6 kilogram block is the force of tension. That one's trying to move in a clockwise direction. And that means that the force of gravity 1 is pulling in the other direction, so that is our negative force. We're out of forces. So that equals the mass times the acceleration of the block. I'll put a little 1 there, make sure we know that's mass 1. Now for the other block, tension is not going in the positive direction. It wants to go in the counterclockwise direction. So instead, force of gravity 2 is our positive force, and tension is our negative force. And that's going to equal the mass of block 2 multiplied by the acceleration of that block. Now the accelerations are going to be the same because the blocks are tied together. One can't fall faster than the other one goes up. What I have are two equations, and it's a set of simultaneous equations. I've got two variables I don't know. I don't know the tension, and I don't know the acceleration. What we can do, mathematically we are allowed, is add these two equations together, and what will happen is our positive tension and negative tension, positive t minus t, are going to cancel. They will go away, leaving me on the left side with force of gravity 2 minus force of gravity 1. And on the right side, I have m1a plus m2a. And I'm still trying to solve for acceleration. I've got it in two different spots. I've got it in this term and in this term. So mathematically what we can do is we can factor it out. My left side remains unchanged, force of gravity 2 minus force of gravity 1. And on the right side, I factored out my a, which leaves m1 and m2 in parentheses. I can now divide the m's over to my left side, and algebraically I am done. I will have force of gravity 2 minus force of gravity 1 divided by m1 plus m2. And that will give me the acceleration. To finish, I'm going to plug in what I know the equations are for force of gravity 1 and 2. So that would be force of gravity 2 is the mass, which is 4 kilograms times 9.8 meters per second squared, minus force of gravity 1, which is 6 kilograms times 9.8 meters per second squared. And I divide that by my masses, which are 6 kilograms and 4 kilograms. And all that should give me the acceleration. When I plug that into my calculator, I get negative 1.96 meters per second squared for my acceleration. The end.